Alright guys, so in these videos we're going to look at a couple different functions, and we want to prove whether some functions are even, odd, or neither. So just to recap what we're going to be going through, if we want to prove that a particular function is even, we show that when we pick a value and plug that value in, we get the same output as if we were to plug in the opposite of that value, or in other words, that f of a equals f of negative a. If we want to prove that it's odd, we show that f of negative a is equal to negative f of a. And if neither one of these conditions happens, then we would say that it's neither even nor odd. Alright, so let's go ahead and look at a proof of one of these things. For this one, we want to prove that f of x equals 3x squared plus 4 is even, odd, or neither. And like always, we want to start this off with a let statement. So we just start off with our function, let f of x equal the function that we're interested in for this particular case. So 3x squared plus 4. And we probably should specify something about the value that we're going to plug in. And that particular value is going to be a. So a is going to be any real number that we plug in. Next step here, let me scroll down a little bit. Is we want to make a statement about what we're about to show algebraically works or does not work. So what we say is, if when we plug in that value, the output of the function is equal to the output when we plug in the opposite value, then we know the function is even. So again, we just want to make a quick statement about what we're going to show, and then we show it algebraically so that people know what we're getting into. So the nice thing about these proofs is really we just need to find what these two values are equal to. So we'll start off with f of a. And plug in a wherever we see an x. We end up with something that looks very familiar. And we want to compare that to f of negative a and see if what comes out is exactly the same. So f of negative a is going to be equal to 3 times negative a squared plus 4. And we simplify that, and we get 3a plus 4. So here we can compare these two. F of a equals f of negative a, and so we're done. We've just shown that this function is even because this particular property holds. So we just need a conclusion. And we can conclude this essentially by saying, since we've shown that f of a equals f of negative a, we know the function is even. And that's it, we're done. So that proof was nice and easy, ended up being even, and that's always the first one that we start with, because if you see up here, we need to find f of negative a to show that it's even, and in the odd proof, we need that f of negative a anyways. So even if this came out to not be even, we now have an expression for f of negative a, and the odd proof is just going to be comparing that expression to negative f of a. So it's actually, the even part is part of the odd proof. And I'll show you that here in a second. Alright, so let's check out another proof here. Different function. And here we want to show that it's even, odd, or neither. So we start off just like normal. We start off with our function. Let g of x equal that function above. And we should probably specify that the number that we're going to be plugging in is just a real number. Alright, so the first thing we're going to do is we're going to start off with the even proof. So we want to make a statement about what we're showing. If g of a is equal to g of negative a, then we know that g of x, this function, is even. So let's go through that process. We know g of a is equal to 2a cubed minus 8x. Minus 8a. Just plug in an a wherever you see an x up top. And g of negative a is equal to 2 times negative a cubed minus, and we're going to plug in negative a here, so minus 8 times a negative a. Simplify this expression here. G of negative a is equal to, we know negative a cubed is going to remain negative, so it's going to be negative 2 a cubed, and that ends up being plus 8a. So we compare these two, g of a and g of negative a, and we see that they're not the same. So since g of a is not the same as g of negative a, this function is not even. Alright, so it's not even, so we move on to the next case here. We're going to look at the odd case to see if this thing is odd or not. So again, we want to make a statement about what we're doing. And what we're doing is if g of negative a is equal to negative g of a, then we know this function g of x is odd. Nice thing about this is we've already done half the work for this thing. We already found the first part, g of negative a, it's up here, so we can just pull that down. So from above, we know that g of negative a is equal to this guy right here, negative 2a cubed plus 8a. So now we need to go and look for, we need to figure out what negative g of a is. And that's just equal to the opposite of whatever that function is with a plugged into it. So it's the opposite of 2a cubed minus 8a. Simplify that, distribute your negative here, and you get negative 2a cubed plus 8a. Compare the two, so here's my negative g of a, here's my g of negative a, and we can see that they're the same function. So we've shown that it is odd. So therefore, since g of negative a is the same as negative g of a, that function is odd. So essentially, just to finish this up, we go through, try to show that it's even. If it's not even, then we try to show that it's odd. And if neither one of these cases work, then we've got the case where it's neither. And that's your conclusion. So therefore, since g of x is not even or odd, it would be neither if neither one of these cases work.